Hi everyone, good afternoon. I'm Anshul Gupta and I'll be presenting today, thanks, on the approach to, the strategy and approach to the electric vehicle development. Where can I presentation? Okay, perfect, thanks. So, just a little bit brief about who we are and what we do. So, Okaya Power Group is basically basically a business group of around 30 years of experience, and we are hailing from electronics manufacturing to real estate and IT divisions. We started off with Microtech as our first company, wherein we were making the computer UPSs, and we later on migrated into battery manufacturing and then into EV. So as a manufacturer, just highlighting a couple of product lines and the capabilities of the company. We are manufacturing EV charging stations, swapping stations, energy storage systems, telecom power solution, lead acid battery, solar home lighting and street lighting system, and now recently in the last 2 years, EVs as well. We are one of the largest manufacturers for inverter batteries in the lead acid domain. Lithium Ion Batteries, I think we are now number second in terms of volumes that we are doing in terms of battery manufacturing. EV charging stations as well, and also indigenized home UPS and inverter sectors. So I have taken the liberty to sort of change the concept right from technical to a little before into the entire approach on how to actually get to the right technical, what the business is actually looking for, how to position yourself, and then accordingly create the product which meets that requirement that the company wants to target. So I've taken a 360-degree approach, and within that approach I am going to be talking more about the 4 areas, in which first one would be the understanding of the market, consumer need, how to use that in order to sort of create your product spec. Moving on to the brand, what does the brand stand for, that the group or the even a startup is sort of looking to create a promise, vision and mission of the company that they're trying to create. Then the approach part, which I will explain with a simple quadrant and a triangular matrix. And then the product development, planning and supply chain, how it all comes together for a efficient manufacturing and a satisfied consumer. So touching on first the understanding of the customer needs. So how practically we took an approach when we were going into EVs, this is all a part of that process. First we started off with understanding of the industry performance, how the industry is doing for the ICE vehicle, which consumer segments are touching, what sort of volumes, how the scooter segments are divided. Predominantly, I'll be talking more about the scooter segment today. Moving on to the product segment performances, the competition trends, segment-specific consumer and dealer surveys, and regional performances. Because the entire India is divided into a lot of different regional basis, patterns and trends. How to decode that and then create a product line which fits for different states. That is what we worked upon. So the biggest thing in the first point I would like to cover is the specific, the segment-specific consumer and dealer survey. What I mean by specific consumer and dealer survey is that when, as a company, we are transitioning into EVs, we had to, talk to a lot of dealers, carry out a lot of regional surveys, nationwide surveys, where we were able to capture the consumers' problems that they were currently facing in both ICE and the electric vehicle space. Focus more towards the electric vehicle space, and then the dealers' problems, because those are the mediums who are actually progressing forward the product and reaching out to the end consumer. So understanding that need really is a very important step before you actually get into the technicals of the product. Then, as a company, what is the brand promise and vision and mission? So in Okaya's case, what I could relate is that when we set out to create a product for the EV space and the EV charging space, we realized that we needed to resonate the product's main features, technical specs, benefits to the end consumer with our brand promise, which was for us trust and reliability. It could be something else for another company, which would be high product spec with a low cost price for the masses. Could be different for different companies. As a startup or a company which is trying to get into the segment, it always makes a lot of sense as a brand what you are committing to the consumer, to your dealers, and accordingly shortlist the areas where you would want to work on the brand promise. So as a vision and mission of the company, we have always been wanting to expand more and more into the greener aspect, making Earth a better place, We have an entire vision and mission statement laid out, and all of our business has been sort of resonating with that overall vision and mission. Anything that does not fit into the vision and mission is not taken up in the business practice itself. So something like this could also be an added approach for the companies who are either big companies transitioning into EVs or any startup. This is where I would like to spend a lot, like a majority of my time, because this is where I feel as a company we have spent a lot of time on, and I urge any company who's into the segment to also sort of see and resonate with different areas. So this is from a source. The source is Al Rees. He's an author into marketing, and how he sort of trains in that book is there are 4 marketing strategies principally. Where first is a defensive strategy, then is an offensive strategy, then it's followed by flanking, and then guerrilla. Now, how to simplify it? I have taken another image from the Bajaj presentation which happened a few years earlier, in which they sort of made the example very clear. If Coca-Cola is the market leader, right? So what are the other companies who are entering into the same segment? How are they going to approach towards it? So, for example, Pepsi took a very different route. They worked on the sweetness. How to have the degree of change in sweetness so that they can, as a brand, do you want to be just another player who's offering another product and you just want to take a pie of the entire business, or you want to create a certain different product which you can, sort of create your brand around. The third option could have been opposite. You go totally opposite. As we all know, Coca-Cola and Pepsi are totally dark in color. So for 7-Up took a very different approach. They went on to a clear drink wherein mothers and children can also sort of move towards that drink in the aerated space. And then there is a niche product like Red Bull, wherein they only focus on energy as a drink, and they've created a niche market. There are 2 other strategies which I will not discuss today, which is discontinuous strategy and the disruptive strategy. So a degree of change less than 10%, if you focus on the right side, the degree of change in the product that you're selecting, if it's less than 10%, it's just a Me Too product. If it's between 10 to 20% of the degree of change, you're probably going to have a defensive strategy. And this is usually suitable for market leaders wherein they're already leading in the product segment, and then 10 to 20% is the area where they focus on. Performance should be 10% better than what it was last year. For example, the CC of the engine, they'll move from 100 to 110, like that. Offense strategy is a little different, where you can take in for the, for example, mileage as a segment. Within our scooter segment, we have seen that a lot of the players have just added product ranges within 10 to 20% or less than 10%, whereas some companies, like I'll take our example, we have sort of went on to the 20 to 33% change in mileage, which is a little bit more aggressive strategy for us to enter and make space for ourselves. Then there's a flanking strategy where you go totally opposite, as I mentioned earlier, and then the guerrilla one, which is a unique, totally different niche market that we are targeting. So once as a brand, as a company, we have shortlisted where exactly and how to penetrate the market, that becomes a very easy way for R&D to sort of come up with products so as to it can meet with the overall brand promise as well as the product differentiation that you want to create. Coming to the next slide, after having shortlisted how do you want to attack the market, what do you want to actually do, then comes the entire drawing board for the product planning team, sourcing team, and the R&D team. So in our case, we have a team which works on just getting sensitivity from the market, talking to consumers and dealers so that we get feedback from time to time, studying the competition, new model rollouts, so that we can always up our game, and then ensuring the benchmark is always up to date. Sourcing as a function works very closely with global and domestic suppliers, in which the vendor selection processes, their capacities, our vision, how are they going to align with that, their quality assurance team, everything is assessed and taken up. I'm just sort of stating the obvious for some people, but just trying to get a little perspective on what sourcing really is. And then product development, where we sort of create those decisions on voltage platforms, the trends, what is going on in the market, what should we select, what will be the technology lasting impact of that, how will the supply chain change. So these 3 departments or functions in an organization play a really key factor, play a really key role in order to specifying the product spec and then bringing it to life, and ensuring that as the market grows, you're able to sustainably provide the product with the manufacturing. And to the left, I've tried to create a product alignment chart. This is how I have done it in our business. So wherein we have one axis with just the mileage side, wherein we're trying to give the different attributes of the vehicle, whether it's going to be high mileage, low mileage, and then you move on to the other axis, wherein mileage is not much of a concern, but users who are young, who are a little bit enthusiastic, they're looking for some performance-based approach. So high speed, agility, design, all of that sort of comes into that space. Talking about price, again, it's the brand, the vision and mission, sort of aligning how to position the product, in which segment do you want to actually position the product. So this becomes a defining moment for the organization, right? So you can have a high price product with better mileage, or you can have a high price product with a better performance, but to have low price product with a high mileage would be a really tough job for the R&D team to sort of work around. So all of these factors, once decided in a company, can really help to strategize how to make the product. Coming to the product development, I'll go a little bit in depth here. As we know, different companies have opted for different voltage platforms. Some have taken 48, some have taken 60, 72, Honda is coming up in 96 volt, and BMW is moving on to 300 plus voltage system for their two-wheelers. So every company is sort of working with their own voltage platform, and everything has its own advantage and disadvantage. So higher the voltage, lower the ampere, so lower the wastage of current through the wire harness. So all of those aspects, once you freeze what you're actually opting for, it becomes a lot easier for the supply chain, manufacturing, everybody to align on that. Chemistry and cell type selection. For example, one of the main attributes for us, safety. So you can either select NMC, LFP, NCA. There are a whole lot of technologies available of cells, and that too in a different packing standard. You can have prismatic, pouch, or cylindrical. Majorly these three sort of cells. Which one to pick, which one suits your purpose as a company. Once you define that, the selection process by elimination works wonders. Motor, should it be brushed or brushless DC? DC or AC motors. Within DC you have brushed and brushless motors. Where to position it, center or the rear side. Again, what sort of comfort you want to give to the rider. How are the axles going to position with it, where the motor will get placed, what will be the braking system. All of these questions get answered once, again coming back to the brand promise, and then the this marketing strategy that you want to opt. Sourcing, as I mentioned, it's global supply chain and vendor selection process. As a company, and I think most of us in the EV space have been working really aggressively on the robustness of the ecosystem. Since the advent of FAME and the indigenization of components has been a vital role for the entire ecosystem to be set up. Vendor selection process and their plans, their management vision becomes a very critical and vital role for the company's success and growth. Capacity mapping and allocation with vendors, and preemptive planning. As you all know, the entire vehicle industry has been facing with the high increase in prices due to mainly shortages of electronic components. There were shipping challenges earlier also. So how you're going to come around those factors in order to have a localized supply chain, less import reliance, and a better inventory control. So when three of these aspects are merged together, wonders can happen for the product and the company. So keeping in mind all of these, I just want to put forward a case study, what we did and how it worked out for us. Applying those four basic areas, what we did, we carried out a survey for around a year in different areas and pockets of India, wherein we figured out range anxiety was one of the major concerns for the consumers. Safety was another aspect where people were sort of hesitant after hearing certain cases in the local newspapers, in the TV, in the media, and everywhere. Then moving on to financing as a challenge, which is a separate challenge altogether, but it's one of the major challenges which the survey gave us as a result. And how different areas, for example, UP would sell more of low-speed scooters, and how South India would probably sell more of high-speed scooters. And then when we went further into the studies, we figured out 1 lakh scooters selling in UP, and other areas were lesser in numbers. However, South and West would sell high numbers with respect to 1 lakh above scooters. So once we fixed up all of those activities and figured out from the survey, we were able to map it with our brand promise. which we draft around our reliability and trust, which is principally our service support. So whether it's EV chargers or EV or batteries or anything that we make, consumers doorstep service is something that we offer, and using that as a way to enter into the segment was plotted. Third one, the go-to-market strategy or GTM. We went on the offensive front, thinking of all the surveys that were, giving us the result. We figured out for us safety would be a key area to work around, and then working on the range anxiety. There is a lot that's happening on charging infrastructure by the government, but at the same time, what we can do as a manufacturer to increase the mileage of the product was, shortlisted, and we came up with the biggest battery pack within LFP battery design into our scooters. A lot of modifications had to be done with respect to incorporating, into the frame. Once we did that, a challenge was put forward into our product development, sourcing, and planning team, wherein we ended up shortlisting a product which was at a 72-volt platform. Although the supply chain is a little bit constrained on 72-volt, electronics at that time, we ended up choosing that because of its unique features and added advantage to the vehicle overall performance. We chose that, and we made the product, whether it's the BMS or the charger, the clusters, DC-DC converter, or all in that range where it can take from 48 volt right up to 72 volt, because we cater to both low speed market as well as high speed. Once the voltage platform was selected, it became very easy for us to sort of work on the electronics procurement, designing of the BMSs, getting the right components, getting the volumes also. Because with each scooter, it's majorly 30% electronics, 40% would be battery, and the rest is mechanical and other things. So 60% or 70% of the supply chain was in our control when we selected this and the subsidiary products with electronics. Moving on, the motor selection. We have so far been working on rear-mounted motors, figuring out the billion-foot rider space, different aspects of the weight ratio of the vehicle, which we selected to put it at the back. However, with the new models which are coming out in motorcycle space, we have decided to make it center mounted. So again, a lot went into on the first three aspects as I was speaking. Those made us select the product's placement and the frame selection as well. Mechanical, what we have chosen, since we want to manufacture and we are manufacturing majority all the things in-house. So mechanical has been also very, like keeping the frame as common as possible into different models and variants across, so that we don't have to incur the frame capex cost again and again for different models. That has been a major decision wherein we have kept the platform absolutely common in our current product range, in the coming product ranges, and which sort of ensures our brand promise to get the service on time and keeping enough stocks around India so that the customer's downtime of the vehicle is less than 24 hours and immediate service could be provided. And one question I keep getting, from time to time, which is on the cell. Why will you be manufacturing cells? What sort of technology would you be, opting out on? So as a practice, till we have reached a certain threshold of volumes wherein a cell manufacturing plant can actually be viable for us, like electronics is. We don't intend to get into it. Reason being, so as a company, we are looking out for changes in technology, and for any company to bet so early on right now, if you don't have the volumes, which technology you want to put a cell manufacturing line becomes a little bit scary as an investor into the company. So we have deliberately kept it out of the question right now, wherein we are focusing to understand the global trends on solid electrolyte, graphene-based batteries. We are also doing some projects with vanadium redox batteries with IIT Delhi. However, this is something which is an ongoing technical, global discussion which keeps happening. How can we improve our battery life? How can we make the vehicle more safe? How can we increase the mileage? So all of these factors, sort of a vehicle platform that you choose and build should be something which is agnostic to all of these factors. So that is the approach that we have taken, so that the vehicle business does not suffer due to any change in technology. So with that, I just want to end my presentation, and thank you so much for listening to me patiently. Thanks a lot.
You said you are making a common frame for all the models.
Right.
So my question is, because when you are taking a common frame, either you are increasing or decreasing the capacity from lower to higher of the vehicle,
right.
basically I'm talking about.
Correct.
And when you are increasing or decreasing the capacity, how you are deciding the size of the frame, whether it is going on the upper side or it is going on the lower side. If it is, listen, if it is on the lower side, then you can make the vehicle on the higher capacity.
Correct.
Because your weights are increasing, your loads are increasing. So what is your approach in that?
So the approach is that once we come up with the concept, we have 3 iterations, and all of these 3 iterations are put into the software. The FAE analysis is done, how the weight balancing is playing out, how the the stresses are coming onto the vehicle. What we have done as of now with our current models, we have placed it on the lower side so that there is more center of gravity available for the vehicle to maneuver around. And for the motorcycle space, we are moving a little bit upwards because the anyway seating spaces are such that it's a little bit aggressive looking, so we're coming with a sports motorcycle. So that frame itself is different. But yeah, so the approach has been to minimize common frame. What I mean is that having a frame and then with minimum changes, the brackets, etc., how we can minimize those changes. But usually it is done with the FAE analysis. We have a team which works on that.
I have one more question.
Yeah, sure.
You said safety is a prime factor
Correct.
for you. What was your approach towards the safety for the two-wheeler? Because it has become a major issue as far as the two-wheeler is concerned.
Correct.
So what approach you had towards the battery temperatures, towards the basically short circuit, because we are working on the 72 volt.
Perfect.
So what was
Good
your
question.
approach?
I really thank you for that, and that is something which is very close to my heart because when we started manufacturing lithium ion batteries in 2017 end, we did both NMC and LFP. Majority share was with LFP with 70%. But the major, when we started looking into the chemistry, the serviceability aspect, and the kind of attributes both the chemistries have, they have their own advantages and disadvantages. The approach was taken, although it will increase our overall battery space, LFP cells. We chose LFP as a, so we discontinued making NMC battery packs way back in 2019 end, when we realized that, okay, as a company, if we have to make scooters, what will we choose? So we selected LFP. And whatever customers we were servicing, we requested them, can we please shift our battery line or battery manufacturing to LFP? But they were constrained with the frame space, so the EH was not coming out. So we deliberately had to opt out with a mutual understanding with the consumers that, okay, as a company, we cannot make NMC, we're moving on to LFP. So a lot of attrition of customers happened during that time. And as of now also, 100% of our batteries are now LFP based. And we are also working right now on the solid electrolyte, wherein how solid electrolyte can play another key role. So I hope that answers. Yeah.
One more point I'll say. Like the battery cover. Few of the two-wheeler manufacturers shifted to plastic from aluminium.
Right.
What is your strategy in that?
So we have done it on, currently we are oscillating between two. We have already shortlisted, we are moving to aluminium die-casted batteries because of the heat sink,
because heat dissipation is not there in the plastic at all.
Correct. So we don't work on plastics.
That's one of the reasons government agencies have given for the fire incidents in the batteries.
So either you need FR grade plastics to sort of give you that heat.
Basically ventilation in the batteries.
Right.
Because I have seen one study at the central of the cells, basically center cells of the battery, the temperatures are very, very high.
Correct. So there can be ways around, because if you look at the global players in China, for example, they still use plastic, but the way they've done it is they have more temperature sensors. For example, actually you will have one at the bottom, one at the right, then one in the middle, and how they all connect with the BMS so that if the temperature rises above a certain point, there's an auto cut. So with our batteries, although we don't work on plastics, we have added around 4 to 6 set temperature thermal NTC connectors, the nodes everywhere in the battery pack, wherein if there's any temperature going off, you can immediately cut off the battery. That is one way. But as you rightly said, plastic is something that we also don't make with respect to the batteries. We only make either sheet metal or aluminium die-casted. We were earlier on aluminium extrusion also, but looking at the thermal sort of factors, we have now chosen aluminium die-casted for all upcoming models.
Thank you.
Thank you so much. Any other question? Yeah.
Sir, as you have mentioned that motor, which currently you are using the rear mounted motor,
Right.
but now you are going to shift to the center mounted.
Correct.
So can you please specify the reason of this change?
Okay, thank you. So the two-wheeler segment for us, it's divided into two areas. One is the motorcycle segment and the other one is the scooter segment. Within the scooter segment, it's all rear mounted as of now because our batteries are huge. So we had to put the cabin, the battery as a placement had to be done a little bit below. So there was no space left for the center mounted motor to be there. However, in our upcoming motorcycle models, we have taken the center mounted belt drive motors in it. That is purely because the belt drive, it's a high performance motorcycle, and there is a certain limitation with respect to the BLDC rear mounted motors. So performance as a factor sort of chooses, because it's a high performance, high price point product, if you remember the graph. So automatically the component selection sort of goes back to selecting those center mounted with belt drive or a chain drive motor. I hope that answers. Okay, thanks.
Let me now take opportunity to introduce Shri Yashodhan Gokhale, Vice President, Energy Storage, Kalyani Powertrain. He is a chemical engineer graduate with 15 plus years of research experience, both academic and professional groups of electric vehicles, energy storage, nanomaterial, chemical, automobile, lithium ion batteries, fuel cells and solid state batteries. He had received Impact Champion Award, EPS RC Research Associate for Silicon Nanoparticles, and Brian Scarlett Award for Outstanding Contribution by Royal Society of Chemistry for Titanium Dioxide and Silver Nanoparticles Research. Today, he is going to give presentation on battery and BMS development for Indian conditions. Sir, I now request you to proceed.
Thank you, everyone. First of all, thanks Dr. Madhusudan Joshi, Udit, for giving the opportunity to talk about batteries and BMS and the challenges. Am I audible to everyone? Yeah. Okay. So I'm going to talk about the few challenges and what we are doing in Kalyani Powertrain. So I just wanted to have an overview, going to talk about the Kalyani Powertrain capabilities, then lithium ion batteries, then manufacturing challenges. People talk about the various things from the different domain point of view, then what's the battery management system, a little bit about the basics, same with the lithium batteries, then the torque pipe, that is our product, and some of the key takeaways. So Kalyani group of companies exist of mainly the Kalyani Steel, then the Bharat Forge, which is the core manufacturing hub, the rank number high position in the forging domain. Then the auto system, we have the automobile axles, then Kalyani Action Wheels and so on. And we have a tie-up with the Refu Germany, Refu Drive, then Teva Motors, then Kalyani Mobility in the US. And the electronics, we have the Kalyani Strategic Systems, analog controls, then Bharat Forge Utilities and so on. So mainly the Kalyani Powertrain Limited started in 2021. It's a 100% subsidy of the Bharat Forge and headquartered in Pune, and our focus areas more on the electric vehicle components, subsystem, powertrain and the vehicle integration. So we have the products like DC-DC inverter in-house, traction motors, aux inverters, so on. So just to talk about the lithium ion batteries, everybody knows, just to give a small overview, there are different types of cells. Cylindrical started 18650, now there is 21700, 4680 by Tesla and so on. And this is the architecture, anode, separator and cathode. And the prismatic cells commonly used by the Samsung earlier times, the BMW i3 used 94H prismatic NMC cells. And this is the architecture, you can see here different terminals, plates and so on. And the pouch cell, where anode, cathode and separator. Pouch cell used by the Volkswagen, then the Nissan Leaf and so on. So as we go forward, you can see there are different battery development started, from lead acid battery to nickel metal hydride, lithium ion battery, and you can see here there is a next generation, there is a innovation happening year by years and so on. Then high capacity batteries, people are talking about the zinc air, aluminium air or sodium air and so on, but still long way to go, and there are some hurdles which are the manufacturing that you will see further. So in general, the lithium ion battery processing consists of mainly two parts: the fabrication, which includes the paste formulation, the recipe. Like we can say the Maggi formula is nice, the Maggi masala or Coca-Cola, it's a unique recipe. Similarly, the companies like Samsung, LG, Panasonic has their unique formulation in terms of the graphite binders on type of the anode side, and on the cathode side you can see the lithium iron phosphate, LFP, then the NMC and so on, and that mixture comes together with the specific rheology to have the different electrode paste, and after that electrode paste you can form the large cells, and then you can do the different testing mechanisms with the cell assembly, then in situ methods to have a characterization for the more robustness. So in general, to give an idea, overall these materials are commonly used in all energy storage domain as well as for the electric mobility. NCA commonly used by the Panasonic and Tesla with specific energy density which is much higher. NMC used in European world as well as the Korean suppliers who make the NMC cells. LFP, which has the energy density, now people are increasing this energy density. And then lithium titanate. You can find out all this information. Just to give you an overview, each and every material has pros and cons in terms of the voltage, cycle life, C rate and so on, and they are used in the different platforms where LTO is a fantastic material but the cost is much higher and the lower energy density. In general, in the battery pack assembly consists of, now people do the different cells, then different cells come together to form the module, and different modules combine to form the big pack, and then the electronic is attached in terms of the bus bars, connectors and battery management system. Somehow I am not able to see the video, but in general, in the battery pack design consists of different cells combined to form the modules. Then modules are arranged in series parallel combination with the different sensors like the voltage sensor, temperature sensors and so on. Then there is a cold plates, thermal management system, which is consists of, from the micro channels you can pass the water glycol solutions. Then you can connect the master slave system, it's the battery management system. In general, in battery pack, lithium ion cells or the cells acts as a heart and the BMS acts as a brain. So each and every cell is monitored with respect to voltage sensors or temperature sensors, and that can give messaging to BMS, and then BMS talk to vehicle control unit. And there are various parameters, battery disconnect unit, high voltage connectors and low voltage and so on. And one of the important critical thing in battery pack manufacturing, there are different processes, like earlier speaker has mentioned about the cell sorting. Cell sorting is a very important area where cells are manufactured by the different cell suppliers, and each cell has a specific internal resistance, voltage, and you have to match that thing with the cell sorting machines where there are different tools. I am just giving you a key idea of what are the processes that people follow in battery pack manufacturing, where cells are coming from your neighboring country or Japan or Korea, and then you can make from cells to module or module to pack. And then there are different contacting of the different current collectors to measure. Then you have to contact with the BMS and the sensor systems for the voltage as well as for the thermal, which plays a very important role. And for that you need a high precision tools, different torques, when you are manufacturing these bus bars or any sensors near to your cells. Then the assembly of all this housing, and then end of line tests. End of line test report, it acts like a complete report of your battery pack. So each and every parameter, voltage, temperature of each and every cell, then your battery pack is IP67, leak proof. Even your cold plates, there is no leaking in between because there is a water glycol solution passes through when you make the liquid cooled battery packs, and then you get a complete end of line report to send your battery pack to the different customers. This just to give an idea, because why it exploded, there is a lot of talks about the battery fire. But in general, there are different parameters in the battery, consist of the anode, cathode, electrolyte. And as you see, as the temperature increases, there are a lot of side reactions like electrolyte decomposition, continuous side reaction, which leads to an explosion or thermal runaway effects. And for that, there are some tools as Mathworks, MATLAB, Simulink gives a great help to indicate or estimate at high temperature what and how it happens. These are the indicators. Then some CFD simulation will give you internal resistance prediction of the temperature. What happens if you charge the cell with the high C rate at 45 degrees C and so on. And at lower temperature also there are various side reactions happens, which leads to thermal runaway events. So we have to control all these things by using the different tools. So I'm going to just talk about the few things. As I mentioned, the cells to form modules and modules to form packs. Cells might be different types, NMC, LFP, then like the combination of the nickel, manganese and so on, and different geometries, cylindrical, prismatic pouch, and you can put the different modules in series parallel combination. And then there are different categories of the battery pack based on ISO 64693, class A, class B, depends on the voltages, and high voltage class and so on. And all these things can be configured into a battery management system. So this brain, how it acts, if you consider the battery, there is always the current and voltage sensors connected near to your cell. They can generate, they can get the data acquisition by using the different safety protection. Then it can communicate, check the thermal management system. It's all this happening because of the sensors which can give message to the BMS, and all interface is connected. And there are two types in the BMS, just to give you an overview. The hardware and software. Hardware consists of SOCs, state of charge determination, state of health determination, cell balancing, fault detection. And software gives you safety, security, sensor system, data acquisition and so on, basically. What functions the BMS do? It can constantly monitor, gather, communicate the data which is getting from the cell during charge and discharge cycles. Then it can see if some of the cell can observe some disturbance or the potential is going down, temperature is getting high because of the whatever the reason, internal resistance. It can protect the pack from the damage. It can raise the alert so the contactors can open and stop the vehicle before it goes to a thermal event. And it can extend your battery life significantly, and it can operate your battery within the limits. BMS is a checkpoint. If the temperature is rises, voltage is rises, BMS raises the alert, tells to VCU, and then that control system starts operating. There are various mechanisms with the failure modes for the BMS. I am not going into much details. Like sometimes the whole system does not work after power up the system. So there are some reasons, short circuit, breaking of the internal wiring harness and so on. Then BMS cannot commute with the vehicle control unit. There are trans receiver failure and signal and so on. and temperature delta is increases. Sometimes the temperature sensor got failed. So there are various parameters which we have to consider while you are designing the software as well as hardware for the BMS. Then this is our baby Torque, the high performance vehicle, and we are coming up in the more manufacturing way in Pune. So you can find out all the information. This is the high voltage 48 volt system using the phase change material for the cooling system with 4 kilowatt hour battery pack and so on. It's already in the production now and it will wrap up on a higher scale. So it's our own PMC motor with 6 kilowatt hour torque and all the single speed transmission and so on. Then the battery pack is in-house developed basically with the NMC chemistry, and there have been a lot of trials in terms of the temperature, voltage over the years with the IP67 and everything. So you can find out all the information. Just to tell you, like, we have this in-house and going now on a bigger scale in India. Then we have developed the high efficiency electric three-wheeler transmission. We provide three-wheeler kit to the different OEMs, and there are advantages like you can improve the gearbox life, high gradability, more range, and so on. If you need, I can share all the details later on. So one of the key points what we are doing in-house, like diversification in terms of Kalyani Powertrain. For drivetrain, for the L5 or three-wheeler system, we are giving like an Amazon kit, like a complete kit for the solution, because all the people want Amazon stick. You can connect, they want Netflix, Hotstar and all that. So powertrain, that includes the batteries, motor, e-axle and so on. And we are giving some of our solutions to swappable and chargeable solutions. Then advance in the 2-speed gearbox, we are certified with the FAME 2. And one of the keys, we are going towards the macro level factories, which can have a distributed manufacturing, which can involve cater in the different domain over the India. And ACCI PLI scheme is gathering with the more on the lithium ion cell manufacturing, and hopefully in next 2 to 3 years we get Make in India cell, which is one of the game changer, we believe. And as earlier speaker has mentioned before in the first session, like though we are talking on a different thing, but still we need a retrain, reskill and redeploy, because the skill workforce is required. People talk about the AI, machine learning, electric vehicles, but can we have capability to work on the high voltage system? This includes the OEM. Can we have a trained people? No. At the moment there is a lot of challenge to get the good people to work on this domain. So that's the way we are going in this direction, and to do more green, we all have to use more electric vehicles in a more affordable way. I hope the time will change soon. So thank you. Yeah, please.
You said you are using phase change material for the cooling of the batteries, I think.
Yeah.
Good afternoon. Good afternoon all. Am I audible? Not a great time to do the session. Okay. Welcome to the session on virtual development of battery electric vehicles. I work for Mathworks. Sunil has introduced Mathworks, MATLAB and Simulink in the morning in a very good way. So I am going to not introduce Mathworks, but I am going to share with you my learnings that I have got from Mathworks while working with multiple worldwide EV leaders. So when I say me, it's not personally me, it's Mathworks learnings. So we have been working with multiple companies in multiple industries for multiple years. And here is my take on my key takeaway. So just for you to understand this slide a little better, this is my key takeaway. The hyperlink everywhere will lead you to that story. So later on, get in touch with me, understand what it is, and you might have a different key takeaway for you. So the first is, I'm sure you must have guessed, it's Tesla. Tesla have been using MATLAB and Simulink since 2008 for their Tesla Roadster. And of course, we do have a success story how they successfully used model-based design for developing controls for their Roadster. But in a recent interview given by Tesla engineers, what we also observed was they could build a very good motor control algorithm which helped them improve motor efficiency by 6 to 8%. And in general, that resulted into 15 to 18% of vehicle range improvement. Now that's significant, isn't it? So my learning is how a component affects the overall vehicle level performance and why everyone should do it. That's why I have included a part in my presentation today. Second, Ather Energy. Again, we have seen how Ather Energy got successful since their IIT Madras days. But one point to share here, just one little detail to add. Ather Energy used MATLAB, Simulink and code generation for their vehicle control unit as well as for their charger. And they have got excellent results by doing that. I do respect that company because of the engineering strength and the engineering investment they are making. Third is about SAIC. I think one of the speakers in the morning mentioned that making one vehicle or making prototype is easy, and making 10,000 vehicles or making production vehicles is always a different ballgame. So SAIC Motors, we have seen them grow from making prototypes to getting to production. What is needed today is mindset change. A lot of Indian vehicle manufacturers today are on this journey. Their recent announcement, you must have seen a lot of new changes happening, and that's what we learned from SAIC Motors. Then the second, this pair is very interesting pair. This is a OEM and this is the supplier. So OEM is Volvo for their XC90 hybrid electric vehicle. Volvo wanted to achieve supplier independence. They wanted to work with any supplier. They did not want to depend on any supplier. So they forced all their suppliers for going AutoSAR way, so that they can change their supplier. That's how they forced LG Chem, their battery management system supplier, to go AutoSAR way. So BMS was developed by LG Chem. They did not just do AutoSAR, but BMS being a safety critical component, they had their own internal quality standards. So they also achieved provisional safety certification. There is a standard called as ISO 26262. So they could do that. Similarly, another good company and another very realistic thing is Neo Car Company. Now this example is interesting. They wanted to build state-of-health cloud-based framework for state-of-health prediction of their vehicles. But they did not have any vehicles because they were a new company. So they built models, they used synthetic data from those models, and then they built whole framework. Once their vehicles got available, then they started using those vehicles for refreshing the data and refreshing their data-driven modeling approach. So that's what we have learned by working with global automotive industry for electrification. Now, when we apply this to Indian 2-3-wheeler battery electric vehicles, how would the workflow look like, or how would the challenges look like? Today I'm going to talk to you about these top 3 challenges. One is about estimating the range and understanding the factors affecting the range in design phase for a battery electric vehicle. Then, as Yashodhan has already covered, challenges related to battery management systems. Obviously, I will not talk about what he has spoken, we'll talk something else about it. And thirdly, which is recent future, is addressing motor control challenges. And that is where I do have my colleague Rahul, who is really expert in working with multiple customers. So, when it comes to a two-wheeler or three-wheeler EV designer, what are his questions? Well, actually, Yashodhan showed us all the answers in the torque example. What would be the target range? What is going to be my 0 to 60 kmph time? What's going to be performance? And things like that. Charging time and things like that. So that's one thing. Secondly, what is the segment we are trying? Are we looking for a two-wheeler or a three-wheeler? Urban or a hilly environment? Is it for a cargo application, or what is that geographic zone? Not every vehicle is meant for driving in city. Some are meant for something else. So that's the thing. And thirdly, cost-related things. Then going to components, which type of motor should be used? Should it be a BLDC or induction machine or the switch inductance machine, which are now possible and which do have a certain advantage as far as magnets are concerned? Then whether I should go for a fixed battery or a swappable battery. A vehicle designer, when he is designing, he needs to think about a lot of different things. The solution is in doing system engineering. Let us quickly understand very high level, what do we mean by system engineering? See, we do have a knowledge about our requirements and our use cases. we build an architecture model by using these requirements. What do we mean by architecture model is we specify the system structure and its behavior. While we do that, we consider different factors like the size, the power, the weight, performance, the attributes which are important to us. That is how we define system characteristics. We iterate, we optimize the overall system architecture. Then we look at it from multiple viewpoints. What do we mean by multiple viewpoints? How does the system look from a battery supplier or a battery manufacturer point of view? Every component. How does the system look from over-the-air updates point of view? So these are multiple viewpoints. We basically use system architecture, system engineering for refining the requirements, and then only we proceed for system design. To summarize, at the end of system engineering phase, we have complete clarity about system architecture model. We do have a system architecture model. We have very good clarity about interfaces between different components of the system. We have a very good idea about the requirements of the system, requirements of different components, and it's also possible to link the requirements to the system architecture model and further to the system design model, which is a requirement as per the functional safety software standard. However, system engineering does not help us answer all the questions. Few questions are written there, like what is the range of my electric vehicle for a particular drive cycle? Like recently we are seeing a lot of vehicle manufacturers are running their vehicles on the hills in nearby cities, and they want to capture what is the range and how does the vehicle perform. So how does my vehicle perform? How do different components behave under extreme load conditions? And will my vehicle control unit be able to handle all different functionalities like regenerative braking, like mode switching between different modes and things like that? So these are some of the questions which are not answered by system engineering. That is where you need to build a system level simulation model of a battery electric vehicle. How does it look like, a system level simulation model? A model which has everything right from the important components. If it's a mid-drive, then mid-drive, otherwise hub motor, then the vehicle dynamics, then it should be capable of simulating different drive cycles, not just different drive cycles, but also things like WOT, wide open throttle. You should be able to conduct different tests on the vehicle. Most importantly, you should be able to swap different components from this vehicle model. You should be able to replace the BLDC by IM, by SRM, and do what-if analysis. That's what a simulation model is meant for, isn't it? So, the picture I'm showing you is built of a model of electric two-wheeler using Simulink, and if you are interested in using this model as a starting point model, we'll be happy to give you this kind of starting point model. Why should one use this model? What is the value of this kind of model? This is the value. Basically, a system level simulation model helps you in doing design optimization. It helps you to maximize the range of your battery electric vehicle. I'm not sure if you are able to see this. I do have a target vehicle. I do have target performance characteristics. What should be my efficiency? What should be cost? Cost of battery in rupees, that's what I'm talking about. Then range and time taken for 0 to 100 km. And then I do have a set of optimizers. I'm not able to remove this, but there is a baseline and I can also optimize all the results. So building a system level simulation model helps us in numerically define the optimization problem statement. Basically making use of optimization capability of MATLAB, define a minimization function and solve that minimization function for a set of constraints. I think this is enough for this session. But to summarize, what I'm trying to say is you can numerically find out, you can numerically optimize different system parameters to get to the best possible design. And a lot of these things are actually subject to constraints. So this is design trade-off. You can either get this or get this, but you need both, so you basically settle for something else in between. Doing a system level simulation also helps you to determine, it gets you clarity about different components of your system. So once I do system level simulation, once I simulate my model for different battery related use cases, I'm much clearer about requirements from my battery system. Who has done this? Royal Enfield. Well, they have done it for a Royal Enfield bike, so they have done it for a conventional bike. It's a SAE paper published by Royal Enfield. How do we know it is because we worked with them for doing this. But they could actually do FE prediction, fuel economy prediction by building a system level simulation model. When and if they go for electric vehicle, don't you think they do already have a very good starting point? Looking at history, most of the conventional vehicles have electrified their existing platforms before coming up with new platforms. So maybe off to a good starting point. So I was talking about this technique. Building vehicle level simulation model helps you to get very clear idea about your requirements related to different components. Now these requirements can be given to the battery supplier or can be given to the battery team, which is in-house battery team. Now let's quickly shift into that shoes, the battery engineer, battery system engineer shoes. What are his challenges? Matching the battery size, battery power output to the requirements, then ensuring robust thermal management. That's like a very important challenge for us nowadays. Ensure that the BMS handles different normal as well as fault conditions in a decent manner, and it communicates whatever it needs to communicate with the VCU in a good manner. So these are some of the high level challenges of a battery system engineer. Now what I'm going to do is I'm going to get one level deep into this, planning to show you 5 workflow steps in a very brief manner. There is a model again available. If you are doing something like this, we'll be happy to share the model with you. Have a look at the first step. It's basically modeling the battery cell. A very popular and it works kind of approach for modeling battery cell is use electrical equivalent circuit of the battery. So understand RC time constant and build the RC circuit of battery. It is not just electrical but also the thermal model. So we are building battery electric and thermal model at a cell level. Second step, we copy paste different cells, connect them to each other and build a battery pack. So we are stacking the electrical as well as thermal effects of the battery. Third step, we model the cell supervisory circuits, the important things which is like putting temperature sensors, voltage and current sensors at the right places in the model as well. Fourthly, this enables us to design the important BMS functions. Some of the functions are thermal management, state of charge estimation and things like that. So there are multiple techniques for doing this. If you are into BMS, state of charge estimation is a good challenge, like sought after challenge. There are many different challenges like Coulomb counting is there, then there is Kalman filter. Nowadays we have also seen people collect a lot of data and they are successfully able to use deep learning based techniques for doing SOC estimation. All these algorithms can be deployed onto the electronic control later on. Once you do this, the end result model is a closed loop model of battery and BMS. What I mean by plant here is this is a 16P6S battery cell and the BMS, battery management system. This is the model I can give you if you are working on something similar. Having this is another great advantage. You can simulate different use cases which occur on the vehicle. But you can also simulate different use cases which do not typically occur on the vehicle or which cannot be reproduced. Something like thermal runaway. You cannot physically cause a thermal runaway, but in simulation it's easily doable, right? And then you can see how your BMS responds to it. Of course, I don't know what you can do for, you can probably prevent it. Once it happens, you can probably not do anything about it. So once you test the battery plant and controller model to your satisfaction, to your requirements, then you can generate code out of the BMS and deploy it onto an electronic control unit. This is what was done by Ather. I don't think for their BMS, but for their vehicle control unit. They built the whole vehicle model, the controller model, tested it in closed loop fashion, and then they generated code out of the controller. At a high level, that's the workflow. So these are the 5 steps for BMS. Now let's go back. Okay, there are, Mathworks website does have a lot of material available if you are doing SOC estimation or VME of your battery or modeling battery packs and things like that. So let's go back to the motor part of it now. Now we are done with this. We have understood how we can build a system level simulation model of a two-wheeler and do range estimation or range optimization for that matter. It helps us to clarify our requirements for different components. We have also seen at a high level what are the challenges with respect to battery system modeling and battery management design. And now let's move on to the last part, which is motor and motor MCU, motor control unit. Now what are the challenges for the motor control engineers? Similar set of challenges. How do I know if my motor controller will produce the desired performance? It works well in isolation. Will it be able to work when I integrate it with the vehicle? Hopefully it will not have any EMI, EMC effects onto it. What happens when the vehicle is loaded? Will my motor and motor control be able to perform to the expectation? It should not get overheated and it should not lose out on those things. So these are some of the things. So what you need here is, it's not just about motor, it is about motor and inverter, motor and power electronics. You need to build overall, for motor control development, you need to build different fidelity models of your motor as well as your power electronics. For example, you can build a power electronics model which is an averaged mode model. So there is no switching happening here. This is very good model for fast simulation and very good model for designing control for it. Then you can add power electronics switching details to your model, and you can also add the thermal dynamics of your power electronics. It is also possible to build thermal model of your motor. One of the challenges that we were discussing just now was for racing bikes, it seems the motor is giving problem at a high level. So can we do field weakening control, and what is the thermal performance of the motor? All that analysis can very well be done in a simulation model if we build thermal model of motor as well. It is also possible, if you have a motor design team, it is also possible to bring in the FEA simulation data into Simulink environment for testing your MCU, for testing your motor control algorithm. So that's also, like if you have a tool like ANSYS Maxwell or JMAC, that data can be brought into Simulink and you can always use that for verifying your controller performance. So that's about motor control. That's about motor modeling. If you look into motor control, look at this flowchart carefully. This is just a high-level representation of steps required for designing motor control algorithm. Steps, the first 4 steps indicate motor modeling workflow. So what are the different approaches? We just discussed a few approaches for modeling motor. But when you have a motor physically available with you, you can directly capture some data from that motor for parameterizing the motor model. Then you can get into control design and code generation workflow, wherein you can quickly design field-oriented control, generate code from it, verify it, and deploy it onto hardware as well. Our workflow is supporting many leading hardware boards like Texas Instruments and NXP and few more boards for code generation. When I say they are supported, you do not have to write a single line of code by hand. That's what I mean by that. Otherwise, you can always generate C code out of a Simulink model. You can always manually integrate it with your IDE. That is always possible. The tool, the workflow is supported by this tool called as Motor Control Boxer. It does have multiple preset experiments, multiple sensor models, multiple observer models, and preset workflows which help you to quickly design controller for your motor, including PMSM and SRM, and then deploy it onto hardware. Like in case of battery, we do have a set of resources available on the website. There are series in terms of, there are 6 videos for motor control. If you are new, maybe you can get started using that. Why am I talking about motor is, see, nowadays, because of FAME 2, making batteries or BMS in India is happening today. But if you really look at the trends, the future is going to be doing motor control in-house. Because slowly competition is increasing. Everyone needs to have a differentiating product. Also remember what benefit Tesla got by doing motor control in-house. So a lot of things are pointing towards that, hence spending some time there. So to summarize, point 1 is simulating full vehicle model helps in doing range estimation as well as range optimization. It also helps you to do component sizing. Secondly, building closed loop battery model. By closed loop, we mean battery cell, battery pack, as well as battery management system model. It's critical for BMS development as well as for hardware in the loop validation. We did not talk about it in today's presentation. And thirdly, motor and power control design workflow requires quick simulation and rapid prototyping capability. Most of the times, if you have a motor, doing this becomes a lot easier by using motor control boxer. So this presentation had several links, several publicly available user stories. Initially, I presented my views to you also. What are my key takeaways by learning from EV leaders? You might have different workflows. So if you want to receive the deck so that you can share the story, you can read the stories for yourself, you can get in touch with me. And thank you for your time.
Hi, good afternoon. I think since the morning we are going through all the product designing, so by now the product is ready in the hand. And once the product is available, so it needs to be evaluated. So I am going to present to you about what is the homologation process or the type approval process which has to be followed. So I'll be touching upon basically the areas on what is actually the battery operated vehicle. There are a lot of concerns on maybe you people are more experienced, but there are many in the morning we had some person saying that we have 400 odd companies which are mushrooming. So there are a lot of companies which are mushrooming and they need to know about what category and what are the products which needs to be evaluated. Right, and I'll be also touching upon what is the international regulations being developed and how we are aligned to that. The upcoming regulations which you need to be prepared for. What are the incentive schemes where the states are covering and the challenges, also the recall and the amendment in the Motor Vehicle Act. As a manufacturer, you need to be aware of both the risk and the opportunities which are available in the whole process. So talking about the battery operated vehicles. So the definition is very simple. It is available that which is powered and exclusively by the electric motor and whose traction energy. So here we have to be very careful that talking about the traction energy has to be exclusively from the traction battery only. So if you see the graph here, so the category of the two-wheeler which we popularly define into three categories. One is the smaller square here which is white in color, then is the yellow and then the orange. So we have the different criteria in which the vehicles are divided. So the L1 and L2 which we popularly call as two-wheelers.
Slide's
So
not
the
moving. The slide isn't moving.
Am I able to hear?
The slide isn't moving.
Not moving.
Not moving. Yes, the slide is not moving. Now. So this was the slide which I was talking about. So in India, we divide the two-wheeler into the three categories. So we have the yellow part and the orange part, which popularly people know as the two-wheelers which undergo the type approval process. The white part, which is the exempted battery operated vehicles. So we'll touch upon each and every category and then come to it. So talking about this, then L1, we have the bifurcation where we talk about the speed, which should be less than or equal to 70 km per hour, and the motor power up to 4 kilowatt. So this was also an amendment which happened recently to align ourselves with the European regulations. Earlier it was like 0.25 only. Then we have the L2 category, which talks about the power, which is the power exceeding 4 kilowatt. We also have the most popularly now known as exempted BOVs, but these are not exempted per se, but these are actually not covered under the motor vehicle domain. So the members will have to undergo the testing, which are the limited tests, need to qualify them and need to ensure that they have the test reports available for the same. So here we have the limitation of 25 km per hour. The wattage or the 30-minute power is 0.25 kilowatt and the unladen weight without battery is 60 kgs. But these needs to be qualified and the members need to have the test reports for the same. Going ahead on the three-wheelers, which we call as a Bajaj or anyone which is available, they are actually the L5 categories, right? So the L5 categories, we have those vehicles which are exceeding 25 kilometer and has the engine capacity of the power of 0.25 kilowatt and more. So we again have the category in the three-wheeler which we define as the three-wheeler passenger carrier and the goods carrier. So these are the definitions which are explicitly available in the CMDR, and if possible, they are also, if one can go through the IS standards, there are few IS standards which are freely available. The members can review those things and come back with the definitions. Then we have this e-rickshaw and e-cart category. This was basically came up with the last mile connectivity to support the people who are moving from the metros and to the short time journey and all those things. So e-rickshaw actually is the vehicle which power should not be more than 2000 watt, the speed not more than 25 km per hour, and they can be used for hire or reward purposes. Similarly, we do have the e-cart. E-cart would be the last mile for only the carrying goods, for the facility to carry goods under this category. So this is a picture which maybe many people who have undergone the design and other things are familiar with it, but then we'll be just touching upon what is the REES, that is the Rechargeable Electric Energy Storage System. So the REES includes the subsystems and ancillaries which are actually physically supporting the thermal management, electronic controls and all the other enclosures. So this is what will undergo the testing from the homologation perspective. Talking of the international regulations, the basic regulation which came is UNR 136, which talks about the electric powertrain. But in India, we do have different words being used, like battery operated vehicles, then we have pure electric vehicles. Some people call it as the electric vehicles only, or the vehicles where we have a lot of, we don't have uniformity of the definitions, because we evolved, suddenly with those vehicles which were mushrooming. Suddenly, like in 2005-6, we had low speed vehicles which were, pumped in from China, and then we had this e-rickshaws coming in. So we are trying to reform and uniformize all the definitions which are available today. So the concerns or the background which has been taken today is considerably from the UNR 101 and UNR 136. So there will be a lot of terms where you will find still in our standards there will be missing definitions. So in case you have to go back and understand what these definitions actually mean, then please refer to the UNR EC regulations. And I think in a year's time we will try to regulate all those definitions and have the uniformity across the standards. So applicable regulations in India, these are quite limited standards, because if you get into it, there is a number of standards which you will have to comply with it. But the basic standards which the members should know is the EMC standards, like each and every component should be EMC compliant. Then we do have the constructional and safety features which are to be complied as per AIS 38 revision 1. The measurement of the electric energy and the range, which are the two critical parameters which is being considered in case of the incentives and the other platforms. It is AIS 39 revision 1, AIS 40 revision 1. We do have the maximum 30-minute power calculations based on the AIS 41. And the battery, which is the REES, which goes as per the 48. The whole approval process, the type approval process, we do have different categories which have their own defined procedures available. So if I talk about an IC vehicle, so we go with AIS 17. So AIS 17 becomes, the father-like standard which governs what principle has to be adopted for the type approval process. So if I have to undergo an electric vehicle for the certification purposes, we'll have to follow the AIS 49, which is revision 1, which consolidates the requirements in one place, and then the individual standards can be referred to. So talking about the less than 250 watt, which we were talking about exempted under the motor vehicle. So currently only the motor power and the speed tests are being done. Rest are the physical verifications and no other test. Since many states have undergone the incentive schemes, and the FAME also is undergoing a lot of revisions, like FAME 1 had a different principle, FAME 2 had a different principle, and now we will be also moving towards FAME 3. So we have also got guidance or the directions from the ministries to do the plant audits. It has been found, and there are many grievances which we receive from time to time, that the plants don't exist and the people are manufacturing or assembling the things. So we have initiated this plant audit requirement for all the categories of electric vehicles initially. So talking about the upcoming regulations, we have AIS 156, which is now divided into two parts. This is with regard to the electric safety and the REES for the safety purposes. And AIS 38 revision 2, which is talking about again two parts, which is talking about the specific requirements for the safety and the powertrain. The next major upcoming is the whole vehicle COP. Now this whole vehicle COP is applicable for all the categories except for the tractors and the CVs currently. Since we are talking about the two-wheelers here, so two-wheelers L1 and L2, e-rickshaws and e-carts are covered under this category, not the exempted vehicle per se, because they don't fall under the Motor Vehicle Act, Motor Vehicle rules. So whole vehicles SCOP, which we call it popularly as WSCOP. So this is governed by the standard which is AI 17 Part 6. So this will be initiated from December 2022. The frequency of the conformity of production has to be carried out within the first 2 years. So every family will be going through the WSCOP, and those families have to be defined and submitted to the test agency for the approval processes. So the frequency, when we say it's a 2 years, meaning this is the first time when we are coming up with very different kind of the standard wherein if you actually see from the BS6 perspective, we have in-service conformity also, wherein we are picking the vehicles from the road, meaning which are sold to the people. And then now we are moving towards not only the lab tests, but also to the tests which are beyond the lab. Like we will also only talking about the static and dynamic. Now we will be covering some part of the static tests and some part of the dynamic tests. And eventually, maybe 2 years down the line or 3 years down the line, we'll have a roadmap for the entire vehicle test. So these vehicles covered under this category are LMN, e-rickshaws and e-carts. And the period, because since it is starting from December, so the first period will end in the after 2 years, March. Incentive schemes, we all are very familiar with the FAME2 scheme. And also to add on that, many of the states, if we see 22 states have issued their EV policies. And among the union territories, 2 of the union territories have issued their EV policies to promote the electric vehicles. Since few of the states are evolving in this, there will be, time to time the changes which are frequent changes which are happening. So most of the states are trying to follow the Delhi EV policies. Since morning we are talking about the challenges which the EVs are facing, that is the battery operated vehicles. There were repeatedly incidents which happened in this year, and they were reported like in most of the media. Based on that, there was a committee which was adopted by the MORTH, and there were sizable number of vehicles which are to undergo the recall mechanisms. So what we wish to say here is that please maintain the tracking records of all your vehicles, so that in case there is any concern or any feedback which is coming for that vehicle, so whatever parts went into it and all those things, the batch, we should be able to retrieve it, and you can be possibly sure that the parts which were fitted are satisfied, or you need to go for the changes. Coming to the recall, TSR 173E, which was issued in 2021. With this, we have the recall mechanism in place. The recall portal is also available. You can go through it with the parivahan.in. So there is a dashboard and the recall mechanism available. Currently, it's the half built. When I say it's half built, it's like 30% of it is completed, where the inquiries are coming in from the general public. But the action mechanism is being done on the papers. It's not happening through the portal, because there are certain concerns which the portal has to resolve. But the inwards or the grievances are being pumped in from this portal. So there are certain, the volumes which are being listed here, and the fine also is available in the same GSR. So what we only suggest is that it's a request that please sell your vehicles which have a proper TACs, test reports, maintain the speed limits, maintain the power, or maintain the technical specifications as per the prototype approved by the test agencies, and also to maintain the traceability of all critical components, whether it's your motor, whether it's controller, BMS, and all those things, so that you know that where the product is going wrong, or till what time you are sure about the product being satisfied in the market. Just to add on, the Motor Vehicle Amendment Act 2019, which made major changes with respect to the penalties. This was the first time when the Government of India has issued a lot of penalties with respect to the non-compliances. So the compliances go with the tune of 1 lakh to the it's a very huge amount depending upon the number of vehicles sold also. And also the alteration, in case the individual also undergoes an alteration. So the individual is also liable for the fine depending upon 5,000 to 3 months punishment. So this is something which we want you to go through the acts and rules, because today you just directly get the challan, you don't know what is it about. So please be sure about what's happening on the individual front as well as on the manufacturing front. So this is from my side. Thank you. And also to add, since we are a part of the Parivahan and the Vahan listing, so I request like your property, your car also needs to have the nominations also, like so please add your what you call that as so please get yourself updated with respect to your RCs and all those things, because many a times it has been found that your RCs are rejected or it becomes invalid. So from time to time be aware, because those platforms are digitally available. So ensure that you maintain a good tracking with the Parivahan. Thank you. So any questions? Yes, please.
Can you hear me?
Yes.
Yep. For slow speed, what I had below 250 watts, it's suspended. So we already have slow speed scooters below around 250 watt motor equipped with. So is it the testing center now is resuming the test facility for that two-wheeler without license and without insurance, that category?
Like you are talking about we taking up the cases for the testing purposes, yes, we have started it, but the only concern is that we are seeking certain documents and also doing the plant visit. So we
all right, madam. So
visit can be virtual or visit can be physical.
All right, madam. So that requirements would I like to write to your email ID so that we know.
If your case is already running, the team must have got in touch with you. But in case you have not received anything, you can drop a mail to us. Not a problem. So you have a running case, or you are in future you want to do a case?
We already have our first look going to be future. It's not a running case, it's a future.
So once you register with us, you'll get the entire information. But then those people who had the running case, they are getting the information right now.
Because those last year it was suspended, that's why we delayed, and surprisingly I listened to you that you are resuming this idea. It's good for the local, rural, lower middle class. They are looking for EVs. They are also a change in mindset, but we are unable to produce and supply the low cost product for them. So this is a good news for us. Thank you, madam.
Okay. But I only ensure what are assurance from your side that you please provide them a good servicing and ensure that the product is, as per the approved norms only being sold in the market.
Yes, ma'am. We are very particular about after sales service as well as the battery pack manufacturing and supply. Thank you.
So much.
Thank you, ma'am, for these prime additions to the topic. I thank all the delegates for actively participating in this session. We, on the behalf of ICAT, once again extend our gratitude to all the speakers of the session for gracing today's webinar with your presence and insightful presentation. I request Smt Vijayanta Ahuja to acknowledge the speaker by handing over the saplings and mementos. Firstly, to Shri Anshul Gupta. Now to Shri Prasanna Deshpande. Thank you, sir. Now to Shri Yashodhan Gokhale. Thank you, sir. Thank you, ma'am. Srimati. Please give a huge round of applause for her. Thank you, Smt Vijayanta Ahuja, Shri Anshul Gupta, Shri Prasanna Deshpande, and Shri Yashodhan Gokhale for gracing the technical session with your presence and immense knowledge. We shall now disperse for tea, which is served outside this hall. Next session on panel discussion shall begin at 4:30 p.m. Thank you.